Hello, my name is Casey Pitcher, and this is my presentation of the chi-square of independence testing. Our agenda today is going to be giving a definition and when to use chi-square testing. We will be looking at 3 hypotheses from tested samples, and we will look at key takeaways. So a chi-square test is used when variables are nominal. We use it to test whether distributions of categorical variables differ from each other, and it's used to determine if there is a significant relationship between the variables. We use it when nominal variables have 2 or more possible values, and it's used to see the difference between observed values and what we are expecting the values to be. And the variables are mutually exclusive. The first hypothesis test is number of cars by number of default payments. The null hypothesis is that there is no relationship between the number of the cars and the number of payment defaults. The alternative is that there's going to be a relationship between the number of cars and the number of payment defaults. So using PSPP, we conduct a test assuming alpha is 0.05, and we find that no relationship emerged because p-value is 0.351, so it is greater than our alpha, meaning there is no relationship. The second hypothesis test that we did is looking at the level of comfort by the number of payment defaults. The null hypothesis is there's no relationship between comfort and number of defaults. The alternative is that there is a relationship between the level of comfort and the number of payment defaults. Again, using PSPP, assuming alpha is 0.05, we found no relationship emerged because p-value is 0.351, which is greater than alpha. The third hypothesis test is the number of cars by the level of comforts. So our null hypothesis is that there's no relationship between the number of cars and level of comfort. The alternative is that there is a relationship between the number of cars and level of comfort. Again, we used PSPP and found that the p-value is 0.00 with a Kramer's V indicating, or Kramer's V being at a 1, indicating a very strong, perfectly symmetrical relationship. So this slide shows Kramer's V interpretations. We can see that there's different levels of relationship from no relationship, very weak, up to a perfectly symmetrical being 1. Although very rare, it can be done. The key takeaways is the PSPP is a statistical software used to make analysis easier to understand. When a relationship is found between the variables, we use Kramer V to determine the strength of what that relationship is. A perfect symmetrical relationship is when the Kramer's V is equal to 1. And as we saw previous slide, the Kramer's V value can be 0, meaning no relationship, to +1 for a perfect symmetrical relationship. Thank you for listening. If you have any questions, feel free to reach out to me.